I'd like to welcome everyone to the 9th Annual Council on Dairy Cattle Breeding Industry Meeting. I'd also like to extend a special welcome to those who are joining us from around the world on the live stream this morning. My name is Lindsay Warden, and I'm the Chief Operating Officer for Holstein Association USA. And since April, I serve as the CDCB Board Chair. Today's theme is a decade of CDCB, genetic advancement through pre-competitive collaboration, as we celebrate the 10th anniversary of CDCB performing services for the industry related to genetic evaluations and stewarding the National Cooperator Database. I remember the first CDCB industry meeting that was held, I think it was at a hotel out in Middleton on the first day of Expo, and we had nice attendance, but people didn't like that we pulled them away from the core activities of Expo. So later on, the meeting came here, and we've been over in the exhibition hall for many years. But I just think that this new venue that we have this year is tremendous for us, and it's wonderful to see a room full of people here this morning who are all interested in the work that CDCB is doing. We've put together an agenda covering a variety of topics, and we hope that you will all learn something new today. Before we get started, I have just a couple of housekeeping items to cover. In this new space, we just want to point out a couple of amenities. The restrooms are located over here to your left. They're well labeled with signs on the wall. There's a cooler in the back of the room filled with complimentary milk provided by World Dairy Expo, and you can feel free to help yourself to that throughout the meeting. You'll also notice some pastries, coffee, and tea in the back of the room. If you haven't grabbed any yet, we will be taking a break midway through the program, and you're encouraged to help yourself to some then. Because we do have this nice bigger space and we are doing a live stream, if you have questions for the speakers this morning, please raise your hand and somebody will bring you a microphone. Now, without further ado, I want to welcome to the stage our first speaker of the morning, João Dur, CEO of the Council on Dairy Cattle Breeding.
Thank you, Lindsay. Good morning. I tried to say good morning to everybody, but certainly miss some of you, so I'm very glad that you could make it. Actually, I don't see anyone because the light is right here, but I trust you are out there. Okay, so what I'm going to talk about today is nothing new. You probably are not going to learn anything new, but it's good to remember, it's good to put together some thoughts about something that is important. And there's nothing more important in our activity here, in our organization, in our community, than the National Cooperator Database. And I hope I can remind everybody why. So, if we think about dairy cattle breeding, the process of breeding cattle, we have several important steps. We need to have breeding objectives, we need to collect data, we need to put that data into a population database, and then we can do something else, research, genetic evaluation, selection. After we have a genetic evaluation, you can really select the animals, choose which strategies you're going to use, and monitoring performance of the herds, not only the genetics, but also the production and the performance. And then we can have very advanced herd management and long-term planning. But the population database is a fundament that we cannot live without. So, bit of history here. By the way, when you got in, you saw some posters there. We have tried to rescue some of the history of the CDCB in these past 10 years, especially honoring those that have been in our board during those years. So I invite you to take a look at that bit of history there too. But basically, cow records started very early, 1885. In 1905, the first milk recording service started. Then we got in 27, the DHIA association started to get organized. In 1935, people decided that we needed a unique animal ID. We could say it's still a struggle sometimes, but the concept still is old, at least. And the first evaluation came in 1936. And in this process, we have lots of organizations that are still around, but one organization that was really leading the way is USDA. And we will not be here today talking about what we're talking if USDA had not played this significant role in the history. So artificial insemination cooperative started at more or less at the same time. And in 1950, people were tired to type in all these calculations in the calculators and decided, well, it's time for computers. So the first computers came to process the DHIA data. And then there's a big gap of 27 years when we have something really of impact coming into scene, which is protein analysis in milk. And then we started with several things. Type traits started to be recorded in a linear scale. Then somatic cell count came. George Shook is among us for our honor. And he was a pioneer in making somatic cell counts understood. And we learned how to use this tool with him and other pioneer researchers. Calving traits, calving easy, fertility. So we start adding more and more things. And in 2013, there was a transition. This transition is what the 10 years is about. CDCB was already around for 20 years maybe, but in 2013, the industry decided that it was time to take responsibility over the data and over the services, but keep this fundamental partnership with USDA, in which USDA will stop worrying about the everyday services and focus only on this research that has been so fruitful and so important. So the health traits started to get evaluated in 18, and in 2020 we started with feed saved. So this change in 2013 is a result of a collaborative arrangement, which is the Council on Dairy Cattle Breeding, that brought together 4 sectors: the dairy record providers, the record processing centers, the National Association of Animal Breeders, and the Purebred Dairy Cattle Association. And these sectors, they had some conflicts of interest. I mean, they were competing for some space in the market. And within their sectors, also they have competition. But they decided to put aside and say, we need something that is pre-competitive, that will help everybody to grow, everybody to advance in a common goal, which is to empower our dairy producers to make better dairy. So this arrangement also had 2 other partners, let's say. One is USDA, of course. They continue to have access to the data for the research that they do, and they continue to provide support to the program. I mean, we use all the legacy software that they prepared, that they used for over years. The database was created by USDA, so we get everyday interaction with their team to this day. And this transition was really smooth because of their selfless dedication to this cause. But we also have the nominators and genotyping labs that were something that came up more or less at the same time, because we needed someone to offer the service to the farmers. Well, we want to genotype your cow, we have a product, well, but someone has to go there and offer the service, collect the tissue, send to the lab, bring back the results. And this is a new type of business that started with genomics, and they are a very important part of this collaboration. So the purpose of CDCB, basically, steward of the National Cooperative Database. So some people mention, oh, the CDCB database. CDCB doesn't own any data. CDCB only is the steward of the database on behalf of this collaboration. And then, of course, with that kind of data, it's possible to do state-of-the-art research and premier dairy genetic information services. So this is what CDCB is about, basically, keeping the database, allowing state-of-the-art research to be done at CDCB, Agile, at universities, making this data work for the producers, and of course offer the premier dairy genetic information services that USDA was doing before. So when you talk about pre-competitive collaboration, I found this quote, and it's quite interesting to bring that it enables the private sector to effectively address systemic challenges. This is what we have here. We have a systemic challenge. We constantly need to collect data, constantly need to process that data, constantly need to advance in technology and offer the best for the good of the industry. And we do that by coordinating sustainability efforts, incorporating diverse perspectives, resources, expertise, and scaling impactful solutions. So this is not a simple thing. It requires, I hope you can read something. There's supposed to be a cow in the background. I cannot see here, but one of those cool things that you think when you're preparing a presentation. But this is really a delicate arrangement between companies that have their own goals, that have their own perspective, they have their own obligations, but they put aside those things the moment they sit in a room and try to work together. So they have to develop respect, open communication, have to share risks, you have to determine a clear governance, and so on and so forth. So this was not a so simple exercise. Well, what about the cooperative database? So the National Cooperative Database is basically a way to sustain state-of-the-art research, as I said, and develop data-driven processes. And why? Because we want to empower dairy producers to effectively and sustainably manage their businesses. And also by providing valuable insights and tools for informed decision-making. So this is what this database is about. What we want from a database at the national level. So one thing is it has to be representative. So include diversity of the data that we can have. Has to have data quality. That's why we have a major effort from many of our members and from CDCB to constantly certify the data providers. So we also need to have a comprehensive data. So it needs to cover a range of demographic and populational aspects. We cannot just have data from one region or from one specific type of herd or from one breed. We need to be inclusive, we need to be comprehensive. And also we need to have longitudinal data, so across time, so that we can watch the effects of those measures that we're making. So accessibility, we need to have this data being available for the research. If we have this data just for CDCB or just for USDA, we are limiting ourselves because we are not taking advantage of the expertise that is around in the universities and the research centers. And we need to make these people work for the good of the industry as well. And of course, there's ethical and legal compliance. We need to make sure that we respect what data owners want to when they provide data to the database. And of course, we're all about collaboration. That's what CDCB is about. Let's imagine our life or our industry without the database. So, database makes possible several things. So, for example, without the database that we put together all these herds from all these regions, we wouldn't have a real clear idea about the lactation curve, the behavior of our traits like fat, protein, somatic cells. Dr. Schupp wouldn't have been able to do all the work that he did without this cooperative database. Calving easy, fertility, you name it, whatever trait, we need to have a population database to be able to study that and get meaningful results. In terms of population genetics, we talk about genetic variability, irritability, genetic correlations, reliability. Well, there's no way to calculate those things without a database of this kind. Also, for evaluation, all these methods that we have been, well, some of us in the room that are young, like me, will not remember, but the others will remember contemporary comparison, BLUP, relationship matrix. Some people here don't remember progeny testing, imagine. But single step, whatever you name it, this is developed based on this database as well. And we can go on, selection tools, to develop selection indexes, mating systems, evaluation of crossbreds, and also genetic conditions. Now we have, compared to 15 years ago, well, 10 years ago, what we knew about these mutations that we can prevent now by running genetic tests and haplotype tests. Very little. Sorry. Got ahead of myself. And then genomics, the Bovine Genome Project, he had the opportunity to use this database to validate all the studies. Development of SNP chips was based on the database, so on and so forth. So we have to be very grateful that the dairy producers and all the associated industry decided, well, we need to have this centralized database so that we can take advantage and make this industry move ahead. So we need to acknowledge that. So today, it's just a small way to express. We have 96 million animals or with pedigrees, 8 million genotypes. We recently crossed that threshold. 105 million lactations, and you can read the rest of the table there. Of course, feed intake, we still have a small amount because this is very expensive, but we are advancing. We will hear a little bit more about that opportunity later on. So what we do with that, we focus on the genetic evaluation, all these traits that we provide, breeds, parentage verification. So all these services can be done because of the database. And this has helped us to be in the forefront of some of the technologies. So just some examples. CDCB is the only one that is certifying genomic nominators and genotyping labs. And we have already 19 nominators and 9 labs certified that are providing services to the industry. 1.2 million animals genotyped in 2022 only. So we are increasing the number of animals genotyped every year. The genomic relationships between genotyped cows and marketed bulls is made available so that all the industry can avoid matings that would increase inbreeding in the population. We have also our SNP set that we use for evaluations, about 80,000 SNPs, which is different than most countries. And this is in constant monitoring, so we can add more relevant SNPs, so we can retire those that are not informative anymore. 53 chips, different chips from different companies, different countries, have been validated and are currently in use. And this work of validating chips is very important, not only for the industry because we can use the data, but also for those that are developing the chips, because they take advantage of the database to validate their assumptions. And so on and so forth. We can talk about chromosomal abnormalities. George Wiggins is here. He can give you the news about that. Only evaluation system using constructed DUMs. So we are trying to rescue those ancestors that we discover using genomics, but we cannot use that information without having a female that makes the link between the grandsire and the animal. So we have these constructed DUMs that are helping us to expand our pedigrees. Animal genomic evaluation of crossbreds has been a challenge, but we have been offering that for many years already. And of course, the feed save evaluations. So challenges in future direction. I'm not going to talk too much about that because you're going to hear about some of these projects after me. I'm just saying that the data streams are in transformation. And we had a very interesting workshop in August in which we discussed this, the fact that we are now in a globalized situation in which the diversification of data collection and data types and data storage has been increasing dramatically over the years. We also see a lot of concentration on the industry, specialization also, and of course we see that there is a desire and a need for customization of services also. So all that creates a heterogeneity that we need to address. So we need to go after the data that will allow us to give the answers to the producers that are looking for all sorts of answers. So we see the modern herd today. It's not just about milking cows, selling milk, and maybe going to a show. I mean, there's a lot going on, and we have to provide them with what they need. So we are working together, all the sectors within the CDCB collaboration, to bring new types of data and to ensure that the fundamental data that we always had and need even in the future continues to flow into the system. So infrastructure, we have all these different data providers sending data to the National Cooperative Database. We have the genetic evaluation system, and we distribute those evaluations to the industry. But before that, we need to have a quality control system that is done by QCS in the phenotypic data and CDCB at the genotypic data. The data ingestion system is a very complex system that has been developed over the past 30, 40 years, and also the distribution and publication system. So we have been modernizing the legacy with the Web Connect in the interface, and now we're working with IOTA on the data ingestion system. So we are trying to make the machinery ready for the challenges in the future. This one I will just fly through because we will have other things to talk about later. But this is just to say that we have several types of projects that we are working on already, and many of them need more communication because people don't know, so we sponsor research. We are also having research internally with our internal group of researchers, and associated with USDA. We have some development also that is going on inside, and we have several ideas that we are considering for the future. So there's a lot going on, and it's all possible because of the collaboration that we have and the database that we have. So this workshop that we had identified 4 major priorities, which is to improve collaborative communication, data quality and integration, training and resources, and also technology and infrastructure. So the board of directors is working with the staff to get actions, concrete actions to advance in these 4 areas here. So by expanding our capacity, fostering innovation, strengthening partnerships, and diversifying our portfolio, also securing our data streams and quickly adapting to changes, improving communication and developing talents. This is what our challenges are at this moment after 10 years of growth and development. CDCB is positioned to lead the way and provide the dairy genetic tools required for the future success, but only if everyone in this room is part of the story. So we are celebrating a decade of pre-competitive collaboration. We thank everybody that participated. I was going to talk about that, but instead, I invited someone else to tell us a little bit, 5 minutes of story of how easy it was to make this happen. So, Oli Milan, please come here. Oli was the chair of the CDCB board of directors when the new format of CDCB was created and the transition was started. So he hired me. So he's a very important man, you know, and I'm really grateful for Oli. Oli, please.
Thank you very much, João. It was, seems like an eternity ago, and of course it was more than 10 years ago when we started this effort, but we knew the timing was critical to get the management of the national database as well as the calculations in the hand of a broad-based industry group. So as chairman, I appointed a 6-member committee to be the business model committee. And we had Jay Madison and Jamie Zimmerman representing the DHIA. We had Dave Thorbon and Doug Wilson representing NAAB. And we had John Meyer and Neil Smith representing the PDCA, some of the best business minds in the industry. So I was the coordinator or moderator of the group, kind of the secretary, and took the minutes. But that business model that that group put together is effectively the same business model that's in effect here 10 years later. I won't go through all the details of the years that it took to put it together. As you might guess, there were competing interests and some protectionism going on. But clearly the CDCB as well as the dairy industry is grateful for those visionary people that put this together successfully 10 years ago. And it was truly an honor and a privilege for me to be working collaboratively with that board over those several years to put this together. And then to work with the staff, Dwayne Norman and George, who's here with us today, were some of the early staff members that the board and I worked together with. And then to have hired João to lead the council and does lead them today. So again, that's just a little bit of the beginning of the history or whatever got together, but I'm so pleased to see the presentation that João just put together for the efforts that we put together some 10, 12 years ago. Thank you.
We have a plaque here that says, presented to Oli Milan in recognition of your outstanding leadership in conducting the transition of services from USDA to CDCB. After a decade of progress and achievements, the dairy community thanks you and the group of visionaries that set the foundations of a unique pre-competitive collaboration for the benefit of dairy producers. Madison, October 4, 2023. So I'll give it to you, but this is going to you as a representative of a group of people that really work hard to put this together. So thank you very much. Now I would like to call Lindsay back to the stage, and also we would like to call Eddie Ormond, which is one of our retiring directors. Where's Lindsay? Oh, here. Okay. So we also have a plaque for Eddie. So presented to Eddie Ormond with deep appreciation and gratitude for serving on the Council on Dairy Cattle Breeding Board of Directors 2021 and 2023. Your leadership and contributions guided your insight, perseverance, and dedication to supporting the CDCB as a business operation. Thank you for your commitment. And I will hand the microphone back to Lindsay, which is our next speaker. Thank you very much.
All right, thank you, Joao. All right, the clicker here. Okay, so the next thing we have on our agenda for this morning is I'm just going to give a relatively brief recap of the National Cooperator Database Workshop that we had back in August. Joao mentioned this briefly during his report, so we'll just dig into it a little bit more. So we had the event in Chicago in late August. It was almost as hot as it has been this week there, but we had a great turnout nonetheless. We had over 106 participants representing all of the collaborating sectors. And so this was a different type of meeting than what we normally have for CDCB, because it wasn't just the 4 CDCB member sectors, but actually we opened it up and invited all organizations that play a role in CDCB were invited. So you can see the names up on the screen, the DRPCs, DHI organizations, breed associations, AI companies, of course CDCB staff and Agile staff were there, and then also the genomic nominators and labs. They're a group that is absolutely vital to CDCB's core services, but they're not often included in the conversations that we have. So we thought this was a great opportunity to engage that group, and they attended in force, so that tells me that they're quite interested in this as well. And the other thing I thought that was really nice was that again, we had excellent participation from all of the sectors that were invited, and it was really neat because we had people from all levels of the organizations in attendance. So we had, of course, management level people that we see at a lot of the meetings, but we also had a lot of people in attendance that are the people that stay home and actually do the work and interact with the farmers. So I thought it was a really neat opportunity for people of all levels to interact and bring a lot of neat perspectives to the table. So the opening, we started kind of in the evening, and our opening program was what we call the sector showcase. And I think that sometimes those of us that work fairly closely with CDCB services take for granted that everybody understands things at the level that we do. But we recognize with this group, a lot of these people this was maybe some of their first actual exposure to CDCB staff and really talking about CDCB services. So we wanted to make sure that everybody in the room understood the role that others played. And so each sector basically had a representative speak. And you can see the photo and the names up on the screen. Angie Coburn from DRMS represented the dairy records processing sector. Sophie Eaglin from NAB represented the AI organizations. John Gloss from Dairy One represented the DHI sector. Jen Levacy, my colleague at Holstein USA, represented the breed associations, and Emily Piper from Zoetis represented the genomic nominators and lab sector. So basically, each person prepared an presentation on behalf of their sector, basically just explaining the data they worked with, how they interacted with CDCB, how they interacted with other sectors of the industry, so that we could all kind of go into our discussions the next day kind of with the same level of understanding of each other, and I think that was really informative for a lot of the attendees. Wednesday morning, we opened up with a lot of speakers, CDCB staff, you can see up on the screen, as well as John Cole and Amy TePlatt Church, really just kind of digging into some of the projects that CDCB is working on to help give attendees more of a perspective on, again, a lot of the core projects that CDCB is working on that maybe they had not heard of, and so they had a chance to get updated on those things, as well as some of the challenges that CDCB faces as they work with the data in the cooperator database. So following kind of those opening presentations, we had a lot of time for just discussion and table work. So we had a facilitator that kind of posed different questions, and within small groups around the tables that were comprised of people from different sectors, everybody was assigned a table. They discussed those topics and then reported out at the end. And from the CDCB board standpoint, we felt that it was really important that there was some real takeaways for this meeting. We recognize, again, we had over 100 people in attendance. We recognize that a lot of companies made a big investment sending their staff to this meeting, and so we didn't just want it to be a day and a half of good discussion that didn't go anywhere. So we had a real focus on, basically we closed the meeting and asked each sector to get together and say, hey, if you could make some recommendations directly to the CDCB Board of Directors based on what you learned today, what would those be? And so I'll just dig into some of those a little bit more now. Of course, collaboration and communication. If any of you had a chance to read my report yet in the annual report this morning, this was a theme of what I wrote in there. I think it's something that as an industry we can always work on. So improving communication with and among collaborators to ensure consistency in data conflict resolutions, establish feedback mechanisms for data conflict corrections, and maintain collaborator contact lists. And the other item under this heading was to form collaborative working groups with sector representation for decision making and develop an information sharing portal for sectors to exchange information. So one thing I think that was kind of neat in this vein was that I think we all recognize that CDCB could be a real conduit to help foster communication between the sectors. I know there's a lot of individuals from organizations that are communicating all the time on different things, but we felt that there could be an opportunity to foster some more intentional communication to help ensure that we're all working together as efficiently as we possibly can. On the topic of data quality and integration, prioritizing data quality over quantity in all data streams with a focus on core traits and unique data sources rather than duplicating existing data. As we're working on new trait development, we know that phenotypes are king, and trying to come up with novel sources of those phenotypes that are also able to be sourced in an economically sustainable way is very important. And then the other item under this heading was to maintain transparent processes for integrating new data sources and support for DRP sector data collection infrastructure. The next theme that kind of emerged from the comments was around producer engagement. So, of course, we recognize that at the heart of what CDCB does, as well as all of the collaborating sectors, the dairy farmer is the end user of our product. They're the source of most of the data that's in the cooperator database, and so they're really at the heart of what we do. So we want to make sure that we're always engaging directly with the dairy farmers and not just kind of speaking the echo chamber of our own organizations. So the first item was to enhance CDCB's visibility and engagement with producers by utilizing a unified collaborative message focused on pre-competitive collaboration and the value of data contributions by producers, specifically targeting non-contributing and non-processed herds. I think a lot of the collaborating organizations, we all have our own messages that we go out to the farmer with, but this discussion was really around having CDCB help us all craft a unified message. So whether they're hearing from a breed association representative, an AI company representative, the lab they're genomic testing through. We're all giving that same exact message to the farmer so that they're hearing a more consistent message from all of us. And then the second point was to expand the value of CDCB by providing accessible and user-friendly infographics and genetic trend information for producers, while also seeking additional funding sources for data initiatives. The next area that emerged was training and resources. And so 2 items here: conduct regular training sessions for both customer service and technical users. Again, just really emphasizing that we have new people coming into organizations. We have people at all levels of the organization. We want to make sure that they understand the role that CDCB plays and that they're able to have the best information about that they can, as well as provide support for research needs and seek external resources when necessary. Okay, we've just got kind of 2 more slides here. Technology and infrastructure, of course, this is always something that a lot of organizations are contending with, and there was 3 models here, or 3 items here. The first was to innovate to develop sustainable data pipelines and accommodate new technologies. The second was to consider automatic correction of genomic conflicts and simplification of female testing process. And the third, if I can make this out here, it's too small on my notes and too light on the screen. Explore expanding collaborator infrastructure with external groups for broader industry engagement. So again, data is at the core of what we do, and everybody's trying to figure out how to work with new data pipelines to get that into the system and be able to take advantage of it. And finally, the last theme that kind of emerged was just transparency around CDCB projects and services, as well as communicating a more clear roadmap to the industry. So develop a clear roadmap with priorities and timelines of CDCB projects involving sector input to enhance transparency in priority setting and deliverable timelines. So again, this is something that as the CDCB board, we're very well informed of the various projects that staff is working on. We're aware of the research that's going on, but we recognize that there's a gap in how well all of that's communicated to the industry. And the CDCB staff are doing a tremendous amount of things. There's a lot going on, and so we really just need to do a better job of telling that story to everybody and making sure that people are aware of kind of what the roadmap is for these projects, what kind of timeline we're working on, and things like that. So we actually had our every April, August, and December, we have in-person CDCB board meetings as well as monthly calls, but we actually had our August meeting directly after this workshop. And so we had a good chance to kind of talk about things right away, and we have asked the CDCB staff to basically come up with an action plan around a lot of these items. So they're currently working on that, and I know that Joao and his team are actively putting that together, and we'll be seeing some more on that soon, so we're really looking forward to that. In my opinion, I think I can speak on behalf of the rest of the board of directors. We felt this event was highly successful. We were very pleased with the attendance, very pleased with the engagement of everybody that was there. And so I think this is certainly something that we haven't committed to making an annual event or anything, but I think it's certainly something that we'll consider hosting again in the future because a lot of people felt it was quite valuable. Okay, so I think we'll, I guess Katie's saying, is there any questions on the workshop? We've got a minute or two. All right, so without further ado, we'll move right along, and it is now my pleasure to introduce our panel to the stage, and they'll be talking about undesirable genetic factors and genomics' role in discovery. So certainly we'll want audience questions from this, and so you can raise your hand and ask a question, but I think on the center of all or most of the tables there should be a QR code you can scan that will take you to the Slido website where you can actually submit questions online. You can see questions that other people submitted and vote for those online and things like that. So anyway, thank you.
Now I see what you mean. Whew, that is.
Get your sunglasses.
He's ready.
Good morning, and appreciate such a nice crowd. We really appreciate the interest in the CDCB, and when Dr. Durr was presenting and talking about the beginnings, this is a great success story for our industry, and I think without buy-in, all the sectors, everyone has bought in so far, and I think that's the real key to our success. And so our panel this morning, we have a superstar lineup here that I hope I can get them engaged to talk, and I won't have to say much, but I want to make a little bit of an introduction to our topic. My name is Neil Smith. I'm with American Jersey Cattle Association, and I currently serve on the council board of directors, representing the colored breeds for PDCA. Our topic, undesirable genetic factors and genomics role in discovery. We may refer to this as genetic conditions. There's a lot of terminology to be used, and you'll hear several, I'm sure, this morning. But I want to talk a little bit about the steps in the process that are necessary. Of course, we have to have discovery, and that requires reporting. And when we get ready to close, the last line you're going to hear from me is, please address reporting, however you're involved, to the producer level. And we're going to try to take care of that informatively. But reporting is the key to discovery of any genetic condition or undesirable genetic factor. Then we have the investigation step. We have to verify. And then we want to identify. Now that requires testing, genomic testing. This is probably the most powerful tool in my lifetime for the dairy industry. We have tremendous potential for future discovery and management. Then then our industry requires or needs labeling, full transparency. I feel that our industry has bought in. The NAB, all the AI companies are on board. They test and label all the bulls. Your breed associations are doing a great job with that. And then our breeders have to manage it. And if we don't follow those steps successfully, they can't really effectively manage. So we're going to try to talk about that some today too. So, to our panel, I'd like to introduce Dr. Paul Van Raden as the first member of our panel, and ask Paul to give us a little introduction about himself and address how our haplotype calls developed.
All right. Thank you very much, Neil. Paul Van Raden. I've been working at USDA in Beltsville, Maryland since 1988. And so first you may want to know exactly what a haplotype is, which is basically just a short segment of DNA on one chromosome. And when you send the DNA to a lab, you get a genotype, which measures the combined DNA that the calf has from both the sire and the dam, 2 copies of the chromosomes. Then we have to split that out statistically into the paternal chromosome and the maternal chromosome. And the haplotypes we're going to talk about right now are mainly ones where if the sire and the dam provide the same stretch of DNA that has a defect in it, then that can lead to the embryo being lost or the calf being born with defects that are fairly consequential, or that they die immediately after birth. And the way we got started in these was actually a project of Katie Olson when she was a postdoc in our lab. And there was a new genetic defect, brachyspina, that was discovered in Europe, and NAB wanted us to determine, is it the same, can we duplicate or find the same inheritance here? And that worked very well using a haplotype in that particular segment. And then the next day we decided to look at all the chromosomes, all the haplotypes, to see if we could use the same technique to find additional segments that are, when they're inherited, the embryo is lost. And that's how we got our start. And then the next step is to try to find what exact point mutation within that haplotype is causing the trouble, and then we can provide that to the laboratories so that they can develop gene tests to more accurately track the problem.
Okay, thank you, Paul. So, I'm trying to do this respectfully here, so I got to get Dr. George Wiggins next. We kind of brought him out of retirement this morning. So, George, give us a little introduction about yourself and your involvement, and then how has the discovery and understanding of genetic conditions changed with genomics?
Well, thank you. I've been fortunate to work with Paul during his career. I actually started with USDA in '78, and I'd just like to build a little bit on what Paul was saying, is that these haplotypes, when there was deleterious or causing a loss of the genotype, we actually looked at that in terms of loss in fertility. So that was kind of the key, that we looked to say, when is it that we don't find the same haplotype coming from both parents in a live animal? And then similarly, we can look at the fertility to see if there was a depression in fertility from the quotes carrier. So that's really the kind of the goal of this, is to identify animals that appear to have this segment or this haplotype piece of DNA that does cause this reduction in fertility. So that's why instead of saying, oh, lethal genotype or lethal defect, we call them haplotypes affecting fertility. So this has given the industry the opportunity to reduce the frequency of these haplotypes by being alerted to them through the role of genomics. And it just sort of shows that the original emphasis on genomics to have early accurate predictions of genomic value also has had many other benefits, of which this is one.
Okay, thank you. So I'd like to introduce Dr. Matt McClure, who is with ABS Global. And Matt, would you give us a little bit of information about your role with ABS and the industry and related to this topic? And then what has been the historical strategy of the AI industry when undesirable genetic conditions are discovered?
So I'm the lead geneticist at ABS Global here in Madison. And first I wanted to recognize that the AI industry and ABS take genetic defects extremely seriously. You know, we test all of our breeding animals for known genetic defects. We report that. So all of our animals, either through CDCB or our own publications, once we know their defect status, we report that. We don't hide any of this information. We also realize, though, no animal is perfect. Every animal has multiple genetic defects in it. So do we. All of us have them. Most of them are just unknown. They're too rare, so we can't select for them. But once we know the animal's genetic defects, we use that in our mating systems to help decrease the risk of genetic defects while maximizing genetic potential. Just because an animal carries a defect does not exclude it from our breeding program. We look at the severity of the defect, we look at the frequency of that, and its genetic potential, and decide how to use the animal. We also, historically, the AI industry, is very supportive of research into it, and we support CDCB. We support academic researchers. Recently, ABS, we donated sequence data to Chad the cow, which he used to help find the causative allele for muscle weakness. We also had the USDA found the causative allele for Jersey neurological encephalitis legs, or JNS.
Yeah, JNS.
But there wasn't a diagnostic test for it yet. So ABS took the initiative, developed a diagnostic test so we could test our own animals, and then we publicly released it. We had a preprint publication, so the rest of the industry could use that. People like JR could then develop an in-house test for it and offer that commercially, so that everyone else can start selecting their animals and making their decisions to reduce the genetic risk while maximizing the profit.
Excellent explanation, Matt. Thank you. And you just reminded me when I said we need industry reporting. I appreciate your comments on the position ABS, and I think all of our AI companies similar position. Everyone is reporting, but we also want to address at the end of this session reporting at the farm level on something unusual. That also is extremely important. So we need labeling and we need industry cooperation. And you just gave an excellent example of the cooperation by ABS with the industry to help us further investigate and develop, identify and develop testing protocols. So let's get, I gotta get my, I just know Rich Tate as JR. So I'm just going to introduce him as JR with Neogen. And would you give us a little introduction, JR, of your involvement, and then how has chip density impacted the topic?
Thank you, Neil. I have been involved mostly with beef cattle breeding and genetics history. I'm trained as a quantitative geneticist. I worked at a university. I worked for the USDA government for a while, and I've been at Neogen for about 7 years now. And I'm in charge of our R&D department, where we develop the new genotyping platforms as well as interpretations for customers to use the information for breeding and selection purposes. And relative to the densities and things like that, we've been very blessed at Neogen to be able to offer a wide portfolio of different gene-seq genomic profilers of different density. And for relatively small incremental increases in cost, we can deliver like 100K to some entities, or the 65K that we use for our nominations to the CDCB, relative to what those were in the history of the previous platform of a 9,000 SNP density. It increases the resolution of what people like the USDA can look at, roughly 10 to 15 times. So it gives them more opportunity. Normally the process includes imputation to go from the 9K up to the evaluation data set. But if you have the actual genotypes called, you don't rely on the risk of the imputation giving incorrect information. You have the actual content. And that's very beneficial for the resolution of these investigations.
Thank you, JR. We have one more important member of our panel, Mr. Spencer Hackett, who represents our producer. He's the lone active producer on our panel. And he's with Malari Farms. And I'm going to ask Spencer to give us a little bit of more information about himself. And would you address, as a breeder, how do you manage genetic selection around carriers of haplotypes and undesirable conditions?
Well, thank you. A little bit about myself. I come from central Minnesota, just north of St. Cloud. We farm there with my 2 sons. We milk 150 cows. We farm 1,000 acres. Genomics basically kind of discovered us when it first came out in 2007. We had cows that maybe didn't deviate high enough on the other system. Had a couple AI companies that wanted to test some early progeny there. You know, they were always kind of on the bubble of families, and we actually found some stuff in our herd to work with and go from there. My grandfather always said, keep working with the best you got. Don't force it to the top, let it come to the top. What I've learned with the carrier part of it, unfortunately, I like to say that I probably work with as many carriers as anybody. I do not shy away from them. I just learned how to manage them because some of those families seem to have a lot of other really desirable traits we like to bring to the breed or try to bring to the breed and go forward with. I think some of the progress in getting these animals identified early as carriers or whatever has helped us as producers not line them up one on top of the other, sire on dam, which ends up leading to a higher rate of abortions and everything else. And I think having this information available to us has really helped us along with fertility and health trait selections. And by using some of this information on the haplotypes and everything has helped us as producers be able to identify these, not make those alignments where they're both on each side, resulting in a higher percentage of casualties or abortions as we're going. So I feel as a producer, we're on the forefront out there for information. I think it's very important for us to collect data as we see it. I made a very wise decision 37 years ago and married a very, very good calf feeder, as most of us seem to do. And she can identify some of these haplotypes just by sometimes the calves are struggling a little bit before we even get the test results back. I'll tell you she's about 100% accurate, even if she's not. I'm still going to tell you that. But by knowing some of this information and being a producer out there in the field, I think it gives us a great opportunity when we see some of this stuff that even if it hasn't been identified yet, it's so easy nowadays to grab a sample, write it down. The next thing you see a common denominator of 2 or 3 of the same crosses or the same sire or the same dam, and maybe there's going to be a way down the road to research and do some studying and make new discoveries going forward that we haven't discovered or uncovered yet.
Thank you, Spencer. Good explanation. So, one of our industry frustrations, I guess, at least has been for Jersey staff and our board, when we had, and I'll just use J&S as an example, the first affected calf was discovered several years before we got down to the nuts and bolts. And that's very unfortunate. So I mentioned earlier, reporting at the farm level is so very important. So Spencer, when your wife, the genius on your farm, discovers something unusual, what do? Do you report it?
Yes, I can take this way back. We had a mating that actually resulted in 15 calves, of which 7 of them were born deformed and dead. And of course, they were all heifer calves. And this was prior to 2007. Prior to genomic testing and everything, we went as far as sending one of those calves in because it was a very common denominator that we saw. We sent it to what we were advised to at that time was to a university in Iowa. And just for them to, do research and studying on it and try to find what was the common denominator in that mating or whatsoever. Fast forward, it would be so much easier today to grab a hair sample or a tissue sample and maybe collaborate 2 or 3 things that maybe we see in Minnesota and now somebody in Texas might be seeing it, and somebody in another country might be seeing it. I know I've brought it up in discussions that we have on some of these committees. You know, maybe some of these samples could be sent in and labeled as research, you know, just to start to compile some of that data of what we're looking for to try to get in front of this so-called undesirable trait before it becomes an impact on making the most productive animal out there for our dairy producers.
So when my expression about frustration we experienced, you know, we even had a couple board members or former directors who, you know, once we started describing this condition, you know, they would say, you know, I think we had a calf like that last year, but it was a bull calf, so we just euthanized it. And so, you know, that's the kind of situation, maybe innocent, but we can't work with it if we don't learn about it. And Matt, you had played quite an important role in that JNS discovery, and there's other stories, but I mean, do you have any examples of particular case study on something that you'd like to share?
Well, to start with, so I didn't marry a good calf feeder, but I did marry a very smart woman. I do support, you know, the idea of a way to national airport. So my wife and I lived in Ireland for a couple of years, and she helped set up for the Irish Cattle Breeding Federation a national defect reporting center. So any farmer could report in, I got this weird calf, and we'll send a sample out. And once it gets going, you get some interesting cases.
Sure.
So, you know, I've worked on JNS, Weaver syndrome. Yeah, you get some weird ones thrown up. So I actually worked on JNS as a postdoc. We thought it was limber-like, you know, and then
right.
Yeah.
At Jersey, we were pretty suspicious it was just more limber-leg, but it's not.
Yeah. And we started talking to people and said, well, it looks a little a little different. So, you know, my experience, my experience is, you know, have the farmers report it, you know, and try to have, you know, that linkage, you know, what's going on
unusual.
here. Anything
Please
unusual.
report.
You know, sometimes it's not a genetic defect, and that's fine. We'll work with the vets to realize, hey, this is actually a parasite. But report it. You know, report it to your vet, to your AI industry, to your herd books. You know, if you report it to ABS, we keep a record of this, and then we have a couple vets and academic researchers we work with. Report it to someone. You know, we won't think you're a bad producer. We know these are out there. But if it's not reported to us, to anyone, we can't help you.
Yeah. We don't want to treat these genetics like they have the plague either. I think historically in this subject topic, you know, we used pretty much for several decades it was recessive traits, and that's kind of the way back history. But because we didn't have the tools we have today, there was a lot more exclusion, and people just, the best way to make sure they didn't make that mistake was eliminate those genetics from their gene pool going forward. We don't have to do that now. If we can still take advantage of good genetics, and we have the tools to manage it. So the next, JR, the next step I wanted to cover, we've talked about haplotype testing, and then direct testing has been developed in a lot of conditions. And so would you give us a difference, expand on the difference between haplotype testing and reading and a direct test?
So we definitely rely on a lot of partners in this space to help us understand what has been discovered from a haplotype perspective, and then what seems to be the putative causative mutation. And then we often do develop a direct test to be able to enable that kind of information. And a lot of times there is some biology or some understanding that this makes sense for the phenotype that's been observed as to this is the reason this could be, or should be the causative mutation. Getting lots of animals genotyped with the direct test is a very strong way to understand that and manage it even more explicitly. And I think one part of that is There is a possibility, theoretically, that some haplotypes that weren't identified as the haplotype might possibly carry the direct genetic mutation and might be missed that way. And other times the mutation could be early, not time out with the timing of the haplotype designation. So there's a bit of nuance into this in terms of the difference, but the direct gene test is a powerful tool to help with that management of the matings and get a more definitive kind of concept around what is this animal's status in life and how to use it in an effective breeding program. And the whole goal is to increase productivity and efficiency of the production system with things that aren't part of the productivity, the production traits or the health traits or some of those kinds of things. What are some other things to manage and improve fertility and efficiency of breedings and getting cows bred so that they can get into the milking strain?
Excellent. We're going to get into the discovery discussion for the future here in a minute. I got another follow-up question on the same topic. Paul, what happens when the direct test disagrees with the haplotype? Paul.
Well, we generally recommend that the gene test is more accurate. The haplotype tests are usually in the 90-some% accurate, but the gene test can be 99.9% accurate. They're not always that way, and so there is still the possibility when you're developing new chips that the reading, especially for some of these complex mutations such as insertions or deletions, they're not just, most of the things we've discovered, the SNPs are just one letter difference, A, C, G, T. Those are easy to read. But we're starting to find more and more now the more complex where there's DNA missing or extra DNA, and those can disrupt the gene, but they're not always as easy to set up the gene tests for. The reason why the haplotypes can be wrong a lot of times is because we're requiring like 100 SNPs in a row to define the haplotype, and if there are just one or two of those SNPs nearby are wrong, that can indicate a different haplotype, and so within, like, sometimes the whole family, you're getting a blockage of the transmission of the haplotype from the ancestor to the descendants. And what's really become more complex for some of them is when we trace the haplotypes accurately, but there's two different versions of the haplotype. And this has happened with the muscle weakness, with the cholesterol deficiency, and before that even with the CVM, the congenital vertebral malformation, and even with
I'm not going to repeat that.
and even with the dominant red, because two animals may have inherited exactly the same, they have inherited the same haplotype from ancestors, but during one of the generations there was a mutation which causes the defect. And so some of the families have the normal version, other ones have the defective version, and that's the case where gene tests are much more accurate than haplotype tests.
Excellent. Anyone else want to add anything to that? That's pretty deep for me, but I appreciate the good explanation. Any other? So, okay. Katie, how we doing on time? My clock says we're good, so. Okay. We haven't touched on a couple other things, and I think we've covered reporting the conditions pretty well. And you were getting into how we deal with where the development of the direct test has gotten to so far. What's JR? If you want to take this question, future development of these tools. Where can we take this? I guess is
I think in part, Neil, one part of this is we're starting to see, instead of the preliminary information on the haplotypes of they just were never seen in the homozygous state, now that we're getting millions of animals genomically tested and available, we're able to also identify frequencies that aren't as high as expected. So it isn't an absolute lethality, it is some sort of reduced effectiveness or functionality or something like that. So I think there's a little bit of more opportunity to identify deviations from Hardy-Weinberg expectations and investigate and understand that way. Certainly, as we continue to move forward, there will be more sequencing opportunities and different ways potentially to capture the genotypes that go into the evaluations, and there could be extra content available and delivered to key individuals, entities that would leverage that and have it sitting in their database to understand and investigate to some degree on what that looks like. We're still working through some of the process and opportunity to get those tools readily adapted and available into the industry. But we're excited for what the future of that looks like, and the challenge is what is something that we can get collected and have sitting there so people can make more effective decisions in a timely manner instead of potentially having to wait for a direct gene test to be developed. We've got new platforms that we're in the process of working on that may give insights from a functional, curated database standpoint, that these are potentially highly functional mutations that may be of interest in the future. What is the interest and the effect of that has to be determined to some degree, but there could be a very strong tie between these reports of individual animals and what attributes do they contain that we can capture at the same time that we do the primary genomic selection tools for breeding purposes.
Thank you. Excellent. Anybody else want to expand on that? Matt?
I was just going to say what Jared, as you're talking, I expect you to go into muscle weakness. That's a great case to where just because an animal is homozygous for it, we call it, it's not fully penetrant. So just because they have both alleles, they don't show it. It's a different type of genetic defect. So it's a new way we need to think about them and how to manage it. So you could have a calf that is homozygous for it, is perfectly fine. Or, hey, it has trouble a couple days of getting up. Some like us in the morning, we're not as agile in the morning. We need a little help, a little coffee, but then they recover and they're fine. And then the vast majority of them do have issues. So we're finding these new genetic defects that require a slightly different way to think about them. But we just need to recognize it, that, yep, it's a defect, we need to manage it.
So it sounds like chip development is part of the future too. It seems like I remember maybe a 3K chip in the beginning, and that has progressed. Tremendous variety of different SNPs available on a variety of chips.
Definitely. And we're sometimes, Paul brought up a very important part for what is happening here, that it's not just the single AGTC changes that are causing these. Sometimes it is an insertion or a deletion or things like that. As we get an opportunity to look across a lot of different species that we support, at Neogen, a lot of mutations that cause adverse attributes in animals, or sometimes favorable coat color, things like that kind of attributes, they are more complex kinds of mutations and take a different design, a different genetic testing platform, some things like that. So there's some give and take in that space. And I have started to think about this, that the inherent genetic machinery within the cells, sometimes if that is a challenging process for us to develop a genetic test for, that's because the genetic machinery within the cells had challenging attributes to get that replicated and generated throughout the process of meiosis and things like that. So there's a certain amount of recognition that Mother Nature, where she has challenges, maybe we will have challenges as a genetic testing development platform, and how robust and how effective can some of those be. So those are challenges that my team continues to work through as well.
Excellent. Now, I want to go back to the Holstein muscle weakness. A point we wanted to make, I think I was supposed to mention to the audience that you can submit questions via Slido, and I forgot to mention that in the beginning, and I think they have directions how to do that on the screen. So we would welcome questions if submitted through Slido. But the point of still under investigation, I want to mention and remind our producers and breeders, sometimes we do have to be patient with these because we have to be absolutely certain that we're 99.9% sure we have it identified correctly, because misinformation, bad information just causes more problems down the road. Spencer, you want to?
Yes, I wanted to comment a little bit on that. You know, as a producer out there, I'm fortunate enough I get to serve on the GAC committee. I'm involved on this side of it a little bit as well. This muscle weakness thing, we're all on it at basically the same first page of the book, so to speak. These guys back here behind reading the chips and trying to line up the stuff and everything, they haven't had a whole lot of time ahead of us, you know, for this coming out to the producers and everything. It's probably one question that my phone will ring, or I'll get a text on, you know, what's taking so long? You know, why isn't it more available? What's going on? Why doesn't so-and-so carry the test? This thing got brought to the forefront extremely fast. So we're not trying to slow things down or anything. We're trying to be 99.9% accurate with that information when it's coming out to us as producers to make decisions and go forward with it. You know, I think all AI organizations, they're jumping all over it, because us as producers, as customers, we're looking for it. We want to eliminate it. We've seen some of these conditions out there, and yes, there are some awful good programs that can keep these calves alive. And when we see a homozygous one, it's, in my opinion, it's evident there's more than just my wife that can feed calves. But saying that, we're going to have to give us a little bit of time, or give some CDCB and these guys that are working on it to get this test extremely accurate. We're using the information they're giving to us now, but as an organization or anybody, we don't want to print something until we're sure of what we're printing is accurate, just for making sure what we're doing is the most accurate information out there.
That's excellent. And Katie, I think, has a question, but let me ask George one more, and then we'll go to Katie with an audience question. George, you pioneered through just about all of this process. You've been part of the 3K, the 6K, et cetera, et cetera, et cetera, and the development to where we are now. Words of wisdom.
Well, thank you, Neil.
First of all, we can't assume. Where Spencer's talking here, we cannot assume we have a case if we don't test that animal. But that's my side point. But I'd like to hear your thoughts on future development as well.
So, since it's my thoughts, of course, I'm free to say anything I want.
Absolutely.
So I will make a plug for the technology that gives us a chance to do full sequencing, because ultimately that's where we get all the information and can pick out of that what is most useful. And on that front, the sort of the next generation of genotyping probably will be sequence-based, because it has the potential of efficiencies. But you know, it's something we've been talking about for a couple of years now, so I don't want to give you a prediction of when it's going to happen. But Neil mentioned the progression, so it's all a case of cost-benefit. That with the 3K, it was tremendously important because it brought genotyping to the females. before the studs could afford to genotype their males and could have the benefit of the reduced generation interval and the early marketing of more accurate evaluations on young bulls. But then with the 3K, we could go to cows. Then, as JR was saying, we've made tremendous strides in being able to increase the density, which gives us more accuracy. We talk about, in all of this, we know that the measures are very good, but they're not perfect. So even in this issue of haplotype matching, if there's a error in the call, which even at 99.9% accuracy, there will be some. So the technology is really breathtaking as to how it's been able to give us more information at lower cost.
Perfect. And I would add, I've been amazed at the growth of the genomic database. You know, obviously Holstein has the larger, by far the largest database, but the other breeds are very rapidly accumulating and building a stronger genomic tested database. Katie, what's your question?
All right, we have a handful coming in. So we're going to start with, this one is for Paul. For optimal genetic progress, should we label a defect or include the defect's economical impact in an overall economic index?
That's a very good question. I was going to bring that up if somebody didn't. Our genomic predictions right now are additive genetic merit. So they're assuming that one copy or two copies is twice as much of the effect as one copy. Well, that does not apply to these recessive or dominant things. So what we could view these as, we need to predict the additive effect and we need to predict the dominance effect on things like fertility, calf livability, stillbirth. We don't have very easy methods yet to deliver the dominance solutions directly to the producer. So we give them a list of all these, haplotype carriers, and then they have to remember when they're making a mating, oh, this one, it's a carrier of this defect, so do not mate that female to the bull that carries that. That works. I'm not sure exactly what percentage of the population of the cows out there are being bred with mating programs. It used to be pretty high.
I'm not familiar with the percentages.
Yeah, I don't
There
know.
are a lot of mating programs available with the tools to manage that.
But so now these new ones that we're discovering that are even partially penetrant, those it's harder to keep track, especially if we could discover many more with dominance effects. It would be nice in the long term to come up with just an adjustment to the genetic evaluations to include both the additive effect and the dominant or recessive effects. We're not there yet, and so that's why we're hand delivering each new defect on its own.
Okay, do you have another question?
I have a whole list of them. All right, next one on here is, how do they see gene editing playing an important role in the future? Are we going in this direction, at least for undesirable genetic factors?
Who wants to take that one? Matt?
So ABS genus, we do have gene editing. We're working on that in our pigs, the PIC. I would say our viewpoint for a lot of these genetic defects is, yes, we could use gene editing for it, but we have other tools that are much quicker and more efficient. Once you've found the muscle weakness, JNS defect, if you wanted to gene edit that, by the time we would gene edit an embryo, make that individual, we would probably have faster genetic progress if we just use the defect status in our mating decisions. To the previous question, we do internally kind of use the economic importance of the defect.
In-house indexes.
In-house, we look at the frequency of it and we look at the impact of it. J&S, you had the graphs showing up. It was very high when it came out. We selected really hard against that because it was very frequent. Mulefoot today, not really concerned about mulefoot. It's still present in the national population, just very, very low.
Breed trends on the screen. I'm sorry to interrupt you, but you're going to the frequency point, and we need to address that if we can. Perfect. Go ahead.
Yeah. So if you look at these, the trends, pretty much they go up and they start to go down because the cause of allele was found. So you look at that and say, what is your risk? Now, in your herd, maybe you have a genetic defect that is very high, so you want to select strongly against that. Maybe you're not concerned about one that you don't have. If I could say, hey, here's a great sire, sorry, he carries mulefoot, you may not care about that because you don't have any carriers in your herd. So we do use the frequency of it, and we do use the severity of it. It's muscle weakness. The calf dies afterwards. That hits you hard. Holstein haplotype, the abortion is aborted at 2 months of age. It's bad, but it's not as economically bad, and it's not as animal welfare horrible.
So for the audience, I think we have, I believe there's 5 breeds on the chart with multiple conditions listed, and you can see in several cases, not all, but in several cases, the frequency declines very quickly once our breeders know about the condition and have labeled sires, and if you test your females, they will be labeled as carriers or free, and I think that it's a very, very powerful tool to manage from. So the encouragement is we see improvement, the frequencies going in the right direction in most cases, not absolutely all. Do you have another question from the audience?
I do, yes. So related to reporting, wrong one. What's the cost to a producer to sample and submit a research sample on a suspicious animal?
Cost of a phone call? Honestly, if it's one of our producers reported to us, we will send out the tissue sampling device.
If it's in Jersey, we'll help them test it. I think all the breed associations would.
Yeah. All the breed associations, I'm sure CDCB,
USDA. I think that question from the farm level. Spencer, you want to?
I'm a firm believer in we need to report it. Us producers out there are the seed stock of information. And I think if you send it to any of your organizations, eventually if they get 1 or 2 samples sitting on their desk, they're going to just kind of look at them for a while. But if we start reporting something and all of a sudden they see a pattern, I got a feeling they're going to invest some money in going forward and trying to figure out what's there, or what does John Doe see up in Minnesota and also sees in California, and we're also seeing it in another part of the world. So very simple to grab a tissue sample, put a number with it, identification number, or a hair sample, whatever you're doing on your dairy. At least report it, bring it with to some of these events, or send it off to your association of your breed and see what they do with it. If we don't report it, it doesn't get off the farm and it goes down the road with the rendering truck.
I would say that I'm confident most of the breed associations, I know with Jersey, you can go into our website and click on abnormalities and find the reporting form necessary. Very simple to do, and I'm confident Holstein, likewise, hopefully the other breed associations, and likewise, as Matt has said, our industry is also all about sustainability, and without full transparency, our AI companies, they don't want to sell you something that you're going to regret later. And they're in business to keep you in business because they want to stay in business. So I have one more question. How much time we got?
You have about 5 minutes, and I have a
Perfect.
smart person clarification point here if you're willing to take it.
Okay. So this is a little touchy question. So I'm addressing it to everybody who wants to say anything. In some herds, crossbreeding has become pretty popular. It appears that most of the identified undesirable conditions or factors are breed specific. There's some that overlap. Are breeders at risk, or the breed itself at risk of introducing undesirable conditions from other breeds through crossbreeding? I know this is a touchy subject, but
I would say high level, there is a possibility of doing that, and we have seen evidence that animals, not in the dairy industry necessarily, but animals that were not available within the structured breeding programs became used in a different breed as a base to start some interbreeding and things like that, because the policies didn't maintain them as viable candidates within that seed stock population. So there is some risk of that happening, and that's where whenever we have broad-based tools that help facilitate an awareness of what is the risk to the population, we try and give some summary information or things like that, and I'm sure CDCB would be tracking and aware of some of those kinds of things in certain cases. So I would say there is some risk, and you have to think about, is it seed stock, is it commercial production, what's the viability and what's the risk to that population based on the policies and approach implemented.
I would say I've seen this more in the beef cattle side. The diseases we think are in one breed actually are in multiple breeds once you test enough animals. Also with your cross breeding, remember, if you're using, say, Holstein Jersey, Holstein Jersey, Holstein Jersey, you're still at risk. Your crossbred animal could carry HH1. Well, the next time you use a Holstein sire, that crossbred animal is at risk of HH1.
so I'm hearing, if my females are tested, AI companies are testing every bull they offer. We also have a multiple breed evaluation through CDCB. All good tools and methods, strategies. If we, it sounds like if we utilize the tools and information that's available, that potential risk is pretty low. Sounds like. Paul, you want to?
Well, I was going to give a counter example, is that the introgression of bringing in other DNA into a breed is, generally frowned upon. But at some point in the past, the polled, which is another haplotype that we track,
Right.
there were 2 different mutations long ago. They're both in Jerseys, they're both in Holsteins, and I think, and I would not be shocked if other breeds wanted to bring polled in, the old-fashioned way. They're doing that with the slick mutation right now, even in Holsteins. So there are other things which one breed has, which the others don't, which may be worth transferring. You have a little bit of a risk of transferring something unexpected, but you have a very high benefit of transferring in the thing that you really want. That gets back to the gene editing. There's more than one way to move the useful genes around, and we should use all the tools we have.
And we have a lot of tools, a lot of information. So, excellent response and explanation. We have another audience question. Paul, would you address the Holstein muscle weakness and the status of the investigation, where that's at?
All right, the status is that the muscle weakness was discovered by breeder reports. It's not something we could have found very easily using our normal methods, both because of the incomplete penetrance and because it was a new mutation within an existing common normal haplotype. And so because it had these two new features, and because the common haplotype was very common, that sorting out the animals that have the new mutation is still difficult with a haplotype test and with pedigree. It's getting easier because Holstein Association gathered up all the gene tests from the companies and private breeders that were willing to send those in, and so we have those now. And the current status is we in cooperation with CDCB have been testing a couple of new ways to use the information, and we hoped we would have a formal decision of exactly what the best method is, before this meeting. We have a couple of different options, and we want to make sure to choose the better option first instead of releasing the information and then saying, oh, we decided to change it, because there's going to be a lot of animals where the haplotype test is just, the answer is we don't know, because we can't tell whether the normal or the mutated version was inherited, especially for herds where you don't have good pedigree or you don't have the dams genotype. And so we are close to making that decision, and then it still has to go through the official channels to decide whether to release the haplotype, but that's where we're at now.
Thank you very much for that explanation. And it sounds like we're close. Just a little bit more work to do. I think we're at break time, and I think we're going to take a 15-minute break after this session. So I want to thank our panel for excellent discussion, and we sincerely appreciate you sharing your wisdom with us today and information. George chuckles as I said. That was for you, George. So from me and on behalf of the CDCB and the industry, thank you so much for helping us today, and we appreciate it very much. I think it's a 15-minute break. Refreshments in the back.
As you are finding your way back to your seats, we are going to get started here again. I'd like to invite Kristen Gaddis to this stage for CDCB research updates. Then we will hear from Asha Miles with an update on USDA research projects. And after these two presentations, we will open the floor up for questions related to their presentations. Thank you very much, and welcome to the stage, Kristen.
All right, so I have no idea if you guys are to your seats or not because I can see nothing up here. So I will just go ahead and get started and keep us hopefully a little bit on time. So thank you very much, Katie, for the introduction. And let's go ahead and get started. So what I really wanted to do this morning was to give you guys kind of a feel for the broad range of research projects that CDCB is currently involved in. So as you can see, there are a ton of topics that I have listed up here, and I will try and cover them as efficiently as we can in 20 minutes. So starting off with our feed efficiency and emissions project, I wanted to give a little bit of background about how exactly we got to the point that we are today in having feed saved evaluations available. So in 2014 is really when the phenotype collection began with a project funded through NIFA, and the researchers at universities across the country began collecting this individual feed intake data. Coming to 2019, that project was wrapping up. They had learned that we can, in fact, select for animals with higher feed efficiency. So in 2019, we continued that project in collecting additional data through a project funded by CDCB and FFAR. With that project going on and with incoming data continuing, by 2020, CDCB was able to release the feed saved evaluations, and then by August 2021, we incorporated that trait into net merit with a new version of net merit at that time. So now today, we have over 10,000 individual RFI feed saved phenotypes that are going into the evaluations. It's about, I can't see what the numbers were, but a majority from the US Holsteins and then some also coming from Canada. So as this project is wrapping up, we look forward to a new project beginning. This will continue the collection of individual feed intake records on Holsteins, but it will also begin to collect data on enteric methane emissions on those cattle as well. This is going to be made possible through a grant from the Greener Cattle Initiative, which is a consortium of stakeholders, including CDCB, and they are searching for research that supports scientifically based and commercially feasible solutions for reducing methane emissions. That's all I will say now, because later this morning, the lead researcher of this project will give you guys a taste of what's to come. All right, so we've done our feed efficiency and emissions, and now we will move on to some health updates. And under this category, we have several topics to cover. The first of which calls for a little change of color, and that's for brown Swiss health evaluations. So as of August last year, we introduced brown Swiss health evaluations. And given our participation in Interval and the primary efforts of Rodrigo Moda, we now have international data incorporated into those brown Swiss clinical mastitis evaluations. Now, we did this also for Holstein and Jersey evaluations, but we didn't see much change in those results. However, when we incorporate foreign data for the brown Swiss evaluations, we did see a significant benefit. And that is because there are two countries, Switzerland and France, that are contributing a large proportion of these data to Interval. And secondly, all of these bulls that Switzerland and France have clinical mastitis data on also have genotypes at CDCB. So that allowed us to see a significant improvement in our evaluations for clinical mastitis in brown Swiss in the US. Moving on, the next topic in the health category are for Yonis evaluations. This was research that began in Agile around 2009. Recently, we were able to collect some more recent data from cooperation with several DRPCs. And this became an internship project in 2019 for Taylor McWhorter, and then in 2022 for Larissa Novo. So what Larissa most recently did was look at a feasibility study of can we use genetic selection to improve Yonis resistance. The good news there is yes. She identified that we could. There is a manuscript under review currently for her work that she did with CDCB with Journal of Dairy Science. And the next steps are to look at what is the best model moving forward from a production standpoint, and to perform a test run with that model and with the data that we currently have. This is all good news, but there are still several hurdles that we need to get through first before this becomes a public thing. We need to ensure that we have a routine pipeline coming for this data to come in continually. And we also need to address any data sensitivity concerns that may be out there, because Yonis is a little bit more sensitive than some of our other traits that we currently have. So since we initially released health evaluations in April 2018, we have seen significant growth in the number of phenotypic records that we have available, which is great. But given this growth in the number of records that we have, we want to go back in and ensure that the genetic component estimates that we are using reflect the bigger data that we currently have available. So right now we are going in and re-estimating variance components and heritabilities for all the currently evaluated health traits, those 6 that are available currently. And we are testing the impact of each of those updates with the end goal of being able to provide a better evaluation for all the health traits. And the last topic in our health updates is an update on our hoof health initiative. As of this summer, we had data available from both cattle eye and hoof trimmer records for 2 herds, one in Iowa and one in Minnesota. And so with our summer internships, one intern, Jonathan Layton, this was kind of his project to look at this initial raw data coming in, see how we could clean it, see how we can look at it, and see what the best way to use this cattle eye data coming in. So we wanted to see how does mobility score, as it's measured by cattle eye, up to a daily basis for every cow going through the milk parlor, how can we relate that to the hoof trimmer data, and how does it impact when the cow has a lesion? How does it relate to the conformation score, and how do these things impact production or longevity? So that is still a work in progress. That's where we are. There are 2 additional herds that, as of a couple of weeks ago, were recently brought onto the project. One in California with 7,000 cows, and one in Arizona with 4,000. And there are additional herds being brought onto the project as well. Okay, so that covers our health updates. But while we were on the topic of interns and the excellent work that they do for us, I wanted to touch on our other summer intern of this year, Joe Minwar Tibet, and his project focused on investigating the impact of crossbred daughters on bull evaluations. So we wanted to answer the question of, are reliabilities over or underestimated, if at all, due to crossbred daughter information? If we look at the Holstein evaluations, each of these little groupings along the plot is a separate evaluation. And we can see that most of the Holstein bulls are using mostly purebred daughters. There are a few that are using crossbred daughter information. The story changes a little bit when we look at Jersey. It comes almost flipped, where most of our Jersey bulls are having some crossbred daughter information. So for Joe's project, he used data for US bulls without incorporating any genomic or foreign information, just using domestic traditional evaluations. He saw that in Holstein milk yield EBVs, there was a slight bias, but we haven't yet figured out where exactly that was coming from. And he didn't see any large difference in the change of PTAs across time for either Holstein or Jersey. So this was pretty good news. In the next steps, we want to gain a better understanding of these results, figuring out, the answers to what we're seeing, and also investigate the impact of heterosis and how that will impact the reliabilities. So now moving on. So we're not going to touch on milking speed. Milking speed has a task force that was initiated by the CDC board, and that is a project that is in collaboration with Agile. So I will leave that discussion for Dr. Miles when she comes up after me. And we will move on to talking about some more data updates, data research, and modeling updates. So one thing I wanted to point out in this presentation, that it's not just the innovation and research team that is doing research at CDCB. It's almost everyone really has a hand in the research. So this section will focus on what is happening in the genomics team, and specifically in data processing in order to improve efficiency and provide a better user experience. So looking to the future, we have to prepare to be able to handle and process more and more genotypes coming in. We're thinking upwards of 25 million genotypes have to be processed and stored. So in order to do this, the genomics team are looking for ways to simplify ingestion as well as decrease processing time, but at the same time as doing that, we have to always maintain the data quality and integrity. In addition to improving the efficiency, they are always looking and researching ways that they can provide a better user experience, providing a higher quality service, and generating relevant information for the users and for the dairy industry. We want to ensure that our system provides the information that the industry needs at the time and what you will need in the future. So this requires them to constantly be looking at ways to improve, ways to make the system better. Another project that is primarily led by the genomics team is the Constructed ID project, which was implemented, at least beginning, in April 2023. And this is to create constructed IDs in order to link calves to their maternal grandsire and maternal great-grandsire. So as I said, the implementation of this started in April, and the historical updates are happening in phases, so that is still going on as we speak. But overall, the goal of this project is to improve the accuracy. And what we have seen so far is improved genetic and genomic estimations. We're also better able to estimate the inbreeding of these animals, and we have seen a 1-point increase in the reliability based on the Constructed ID project. So now moving on to some more about modeling updates. Andres Lagarde joined our team in January, and his focus is really on looking at the implementation of single-step models to the CDCB evaluation system. So what we're looking for is a pipeline using the BLEP 90 single-step programs that runs actual computations in less than a day. In doing this, we need to identify meaningful results. We need to have genomic PTAs that we can compare, SNP solutions. We need to see that the trends are what we expect, with little or no re-ranking of bulls among those that have many daughters. We wouldn't expect the modeling to really impact how those bulls rank. So some issues that are being addressed or need to be addressed. Our National Cooperative Database is the largest database in the world, the dairy database in the world. So every test that Andres needs to run is taking a few hours or days if we're lucky. It can take much longer as well. So the software that he is using and has written parts of has not been fully optimized yet for a data set that is this large in a production setting like CDCB. So there's a lot of testing to be done, and creating realistic tests is also difficult. The current status of this project is we started with the fertility set of traits. And these are one of the more complex traits that we have. but they are also the traits that could potentially benefit the most from using a single-step model. And if we can get it to work with fertility, then hopefully everything may be a little bit easier going forward. So right now, Andres has worked on model improvements, as well as software improvements, and working on a better theory of how to model missing parents in the model. The next steps are to include genotypes. They have completed a test run with 40,000 genotypes, which is really just a baby play scenario, but it did run successfully. And also testing the use of the APY method, which should improve the efficiency. All right, so we've done our modeling and our data. The next topic is lactation factors, which is another that is a collaboration with the team at Agile. So I'm going to mostly skip over that with only saying that CDCB welcomed a postdoctoral researcher in May, Malia Caputo, and she will be focusing on this project going forward as well. Which brings me to my last topic that I have time for. I wanted to bring up fertility, as it will hopefully bring some new developments and important developments. We know that the implementation of reproductive technologies has really shifted the way our industry works, whether that's through sex semen usage, timed AI protocols, embryo transfer. What we don't have a good grasp on is how that impacts our evaluations and how we need to account for that information in the best way possible. So that is what we are beginning to work on now. We are discussing and thinking of ways that we can look at this and research and try to answer these questions in order to develop better fertility evaluations for the dairy industry. Okay, there we go. All right, so this is really just a flavor of all of the research topics, or some of the research topics that CDCB is currently involved in. 20 minutes doesn't give me a lot of time to go in depth into many of them. But as I said before, I really wanted to focus on the fact that almost everyone at CDCB has some part in the research that is going on. We still work very closely with our colleagues at Agile in accomplishing this research as well. And there are a number of projects going on throughout the land-grant universities in the country, of which CDCB is either a collaborator in the project or supplying data from the National Cooperator Database in order to achieve these research goals. So hopefully I did pretty good. Thank you guys for your attention, and I believe Asha is up next for the Agile update.
Okay, good morning. People weren't kidding, you really are blinded up here. I am very pleased to be here and to share the work that Agile's been doing over the last year. We'll cover a variety of topics today, but I want to dive right in with milking speed first. So in October of 2021, the CDCB Board of Directors appointed a task force to investigate the feasibility of implementing genetic evaluations for milking speed in the US. And we meet regularly in progressing towards this goal. Now, last year at this meeting, we presented these 4 research objectives to you all, and today I'd like to give you an update on the progress. And these objectives really encompass the final goal of standardizing a trait definition for milking speed using quantitative data coming off of inline milk meters. And of course, characterizing and accounting for system or milking management effects as well as biological conditions that can impact that phenotype. So the first step in doing this is assembling a data set that can help us answer these questions. So I'd like to extend special thanks to Robert Fordrain and John Clay at DRMS, who have gone to great lengths to make this type of data available to us. So the type of data we're working with comes from just over 300 herds, It includes 230,000 cows and ultimately over 40 million observations. And the reason for this is because we're working with milk weights and milk durations from every single milking in a day and every single day in a cow's lactation. And so this data becomes exponentially large quite quickly. But this does also describe data from over 31 states, multiple dairy breeds, as well as multiple OEMs or original equipment manufacturers, meter manufacturers, some of which are also robotic systems. Now, this slide is showing an example of some of the really important first steps in parsing how system effects and biological conditions can affect these measurements. So there's a lot happening on this graph here. I'll break it down for you really quickly. So on the y-axis, milking speed is the phenotype we're working with. That's the total milk weights from that particular milking divided by the total number of time the milking took in pounds per minute. The banners across the top there are showing the different meter manufacturers. The banners on the right-hand rows with the number 2 or 3 are showing milking frequency. We're only working with non-robotics data at this moment. And this is just showing data for Holstein and Jersey, for whom we have the most representation in our data set. Holstein is indicated by the red line and Jersey by the blue line. And then, of course, across the x-axis, you have day and milk. And probably the first thing you'll notice is that Bico and Yantech herds that milk at a 2x frequency aren't represented in our data set at all. We simply just don't have data available for them. Similarly, if you were to look at Bomatic herds that milk with a 3x milking frequency, and I'm sorry, I'm going to have to move so I can remember what order my slides are in. You'll notice probably most starkly that the Holstein line here is quite smooth, and that's representing data from over 22,000 cows. So remember, the 40 million observations is related to milkings themselves. That number becomes substantially reduced when we talk about the number of animals represented in the data set. And Jersey, who have a much less consistent line here, represent data from only 167 cows. And so this is one of the major challenges we deal with, where the more we stratify this by things like parity, breed, milking system, milking frequency, we do start to encounter a lot of sparsity in the data. And that does make it more difficult to elucidate trends. This is a challenge that's likely to continue to be relevant as we move forward in collecting data on a large and national scale. However, overall, if we look at these trends, we do see that milking speed tends to mirror the milk production curve as we move through the stages of lactation. This is to be expected given the moderate to high correlations we see with milk yield, both observed in this data set and reported by other independent studies in the literature. Now, a really important question the task force is focused on is whether automatic milking systems, AMS, or robotics herds can be evaluated together with conventional herds. So this graph here is showing information for Holstein only. Again, we have the most data for this breed, so it's easiest to examine trends. You have that same phenotype of milking speed on the y-axis and day in milk across the x, but this time it's OEM that's represented by the different lines. And again, we see milking speed more or less mirroring the milk production curve. What is quite interesting is at first glance, De Laval, indicated by blue, and Lely, indicated by the red line, have quite different milking speeds. And I want to caution everybody that this does not suggest cows milk more slowly on a De Laval system. This is an artifact of how each OEM measures milking duration. When we talk about a robot, the classic example would be box time, total time in the robot, versus milking time, the moment that the unit is attached. And so this is simply to say it's a demonstration of an OEM effect that will need to be accounted for when we're talking about harmonizing data from diverse systems and sources into a single evaluation. Now, the task force has also focused on the relationship of milking speed to other health parameters and extended that to other milk components. And so the approach for this is to average milking speed for all milkings on a test day, and then correlate that directly with the reported somatic cell, fat, and protein on that same respective test day. And the average milking speed for the day is required because we don't know which day or which milking in our data set was used for the test, depending on what plan the herd was on. And so if we look more closely just at somatic cell score for an example, we do see that there is a weak but favorable correlation between the two. And in a similar analysis, we saw that there was no statistically significant association with clinical mastitis diagnosis on the same exact day that the milking speeds were reported. And these results for somatic cell and clinical mastitis are a little bit at odds with what we had expected, given prevailing theories about milking speed being tied to cows that have more mastitis problems, and other reports in smaller scale studies that we've seen in the literature. And one of our theories here is that right now we're treating milking speed like it's a linear trait, and maybe we need to be evaluating it in terms of standard deviations from the mean for that herd. And that maybe any mastitis complications related to cows milking extremely slowly or extremely quickly are being masked by lumping them all together in this quantitative correlation. So some of our next steps will be to look at those extreme groups and see if these trends still hold. Now, what's next on the horizon for milking speed? It's in generating PTAs and heritabilities so we can make a recommendation to the board about how to move forward with this. And so we're very excited. We do have some preliminary data to show in this regard. So we're first taking an average milking speed trait using all available data. So this is an individual cow's average milking speed over all her milkings in a day, every day in her lactation. And we're using complete lactation data only, starting with Holstein and Jersey animals. So this was a sample size of about 20,000 cows, representing data collected over just 1 year. And the heritability for this trait was 0.37, which is encouragingly high. We also examined genetic correlations between this milking speed PTA and somatic cell score, milk yield, and net merit. Now, this is actually an antagonistic correlation, genetic correlation between milking speed and somatic cell score, again, different than the phenotypic correlations I showed on the previous slide. So this here is suggesting that if we're selecting for cows that milk faster, they do tend to have higher somatic cell score. Something that the task force found exceptionally encouraging was the low correlation with net merit. That, especially in concert with the high heritability of the trait itself, suggests that there's a lot of value in a genetic evaluation for milking speed, and that it's bringing something new to the table that's not already being captured in the traits currently included in net merit. And the last thing I'd like to point out here in this example data is that the mean reliability for Holstein bulls was 0.67, but this number ranged all the way up to the high 80s. And this was simply a function of how popular that bull was in our data set and how many daughter records we had available. So next steps here will include examining alternative phenotypes. So one of them being average milking speed, but only from test day data only. This would represent a possibly more feasible approach to capturing this data on a large national scale. The high resolution of every single milking and every single day for every day of a lactation would be a major challenge to have that data flow into the database, whereas adding this to the test day data in the current format where it already flows would be a practical and hopefully expedient way to start collecting this data. And then, of course, we want to examine how heritabilities and PTAs for this trait change using data from primiparous cows only. And this is because our European counterparts, who have evaluations for milking speed based on a subjective categorical scoring system, use data typically only from primiparous animals. Now, that was a very quick overview. The next topic I want to talk about in the time we have here is work we're doing to account for identical animals and clones in genetic evaluations. This is slated for implementation in the December 2023 official evaluations. So how does data about clones reach us in the first place? It's through multiple birth codes. So out of about 7 million genotyped animals, we have nearly 5,000 pairs of natural identical twins. Over 1,700 split embryos and 530 nuclear transfer clones reported to us. So why are we concerned with clones when they make up such a small proportion of animals? The reason is because they multiply the genetic contribution of highly influential animals to the total population. So a good example of this would be considering Apple, who won World Dairy Expo Grand Champion in 2011. She was cloned 9 times. And 2 years later, in 2013, she was beaten by one of her clones for Grand Champion here at Expo once again. Now, Apple herself, the font's a little small here, she had 361 progeny, but her 9 clones altogether added another 325 progeny, effectively doubling the genetic contribution of a single animal to the population. So this is an example of how we want to improve accounting for identical animals. So what did we change? Well, previously the pedigree matrix treated clones as full siblings, but this did lead to an underestimation of pedigree inbreeding. So now the new model stores a source animal for each identical group, and then during the computation of the evaluations, it switches the dam sire ID to this source ID. And what this allows us to do is acknowledge that the animals are genetically identical, but store and keep a separate permanent environment effect for each clone. And so an example of these impacts and results, courtesy of Paul Van Raden, are shown on the right here. So if we consider a calf born in 2020, whose maternal great-grandsire was a clone of the paternal second great-grandsire, in this case it was Manoman and Manoman 2, we found that originally the pedigree inbreeding estimate was 9.8%, because again, it was treating her ancestors as full siblings, not identical animals. Now with this edit, it's been corrected to closer to the true value of 10.6%. And her genomic inbreeding remained the same at 13.5% because, of course, the genotypes themselves are identical. So again, this work is slated for implementation in December of 2023. Now, the next topic I want to talk about is work we've done for standardizing, improving our standardization of lactation yields and the factors used for those estimations. This is also slated for implementation before the end of the year. So how do we measure and compare yields in the first place? Herds who are interested in knowing their yields traditionally participate in DHI testing. A technician travels to the herd and samples part of her yield from one milking in a day. From that single milking, her total daily yield is extrapolated. From that, her total lactation yields are predicted. And then when it comes time to draw fair comparisons across cows performing in different environments, we calculate their 305-day mature equivalents, or 305 MEs. Now, the last time these 305 MEs, the methods for them were estimated was in 1994. And at that point, we performed corrections for parity, age, season of freshening, previous days open, geographical region, and all standardized to a milking frequency of 2x. But we know that genetic selection changes maturity patterns, so after 30 years, it's time to re-estimate these factors. So the data we worked with for this research comprised over 100 million milk and fat lactation records, and just 81 million protein records. The reason for that being we're using historical data and we haven't been collecting information on protein for quite as long. We did not change anything about standardizing to 2x milking frequency or how we're accounting for previous days open, but we did make a lot of improvements to our assessment of season region effects as well as age parity effects. So previously, season region, or the region effects, were calculated across 3 geographical regions representing the East, sort of the Midwest and the South together, and the West. Now we've defined 5 new climate data-based regions, hopefully better capturing seasonal effects on yields. Previously, these calculations were done within breed individually. Now they're done with all breeds together. Now when we consider age parity, previously, age group within parity was how these animals were accounted for, so they were grouped into young, medium, or old within each parity group. Now we're using a more quantitative measure of age in months. And probably the biggest change here is that previously these were standardized or corrected to mature age for each breed. We're now correcting to average age of 36 months. This has been the standard of the traditional PTAs since 2005, so that makes these new 305-day estimates more in line and more consistent with other metrics we're providing to the industry. But it's also more reflective of the cows that producers are actually seeing in their herds, given that very few animals actually reach mature age. I want to give a quick overview of these new climate-based regions. So the U.S. Department of Energy reports climate zones 1 through 8 at the county level, and these are publicly available online and usually used for building codes, insulation, that type of thing. So what we've done is we've averaged these county codes by state and then used that to group states into the overall hottest, indicated by the red there, to coldest regions in the U.S. One of the most burning questions I always get about this slide that I'll just answer now instead of waiting until the end is, why did we average by state instead of using something more like county level resolution? And the biggest reason is we're using historical data and county lines change over time. So it's not necessarily true that that county will apply to the historical data. And also often the records, the address we have on file is the address of the home of the owner, not the location of the herd. So we can examine these factors graphically. Again, there's a lot happening in this plot, but the regions of hot, again in red, all the way to coldest in dark blue are indicated by the banners across the top. Corrections for milk, fat, and protein are shown on the different rows and indicated by the banners on the right-hand side. The value you have on the y-axis is the actual season region correction factor, and the values across the x, 1 through 12, are the month of calving, January through December. And this time the lines here aren't showing breed. Remember, these are evaluated all breeds together. 1990 is showing a group of lactation records, that's the pinkish red line, from 1990 to 94. And then the bluish line is the same thing, but 30 years later, using lactation records from 2015 to 2020. And we can simplify this interpretation a little bit by zooming in on one example, where we can say for all breeds, a cow who calved in June, so that's the middle of the peak there indicated by the 6, in the coldest US climate zones between 1990 and 94, that's the pink line, requires a bigger milk correction than those who calved between 2015 and 2020. And this is actually quite good news. If we're seeing bigger corrections needed for animals in historical data, this means that we're probably doing a better job of controlling the cow's environment now, and we're not seeing the same losses in yields we used to expect with hot season and weather calvings. We can also examine the new age parity factors in the same manner. So this time, because maturity rates do vary a lot by breed, breeds are all evaluated separately. So Ayrshire, Brown Swiss, Guernsey, Holstein, Jersey, and Milking Shorthorn indicated across the top from left to right. This time, each row is a different parity. Parities 1 through 5. We did not re-estimate factors used for 6 and greater parities because those are not used in the regular genetic evaluations except in the case of productive life, so they're not shown here. Your different colored lines are once again showing 1990 to 2015. Your x-axis this time is that age, that quantitative age in months. And again, to kind of simplify interpretation here, we can look at an example with Holstein, where we see that first parity Holsteins who calve at a younger age, so that's the left-hand side, require bigger adjustments. You can see that from the slope of the line. Something that was a little unexpected for us was that the effects differ very little between time periods, and what I mean by that is that those pink and blue lines are sitting almost on top of each other. And this suggests to us that maturity rates may be a little bit more stable than we had initially expected. So we do want to encourage as widespread adoption of these new factors as possible, so the software is available for public use on our website. And this is a pretty hefty URL, so I created a tiny URL. So just /new-factors will direct you right to that site. The download file there indicates a package that has the actual program in it as well as example files, and the website itself functions as the README file. And my contact information will be at the end of the presentation, but also on this website is information of our talented programmer who put this together for you. So please use this as a resource if you're trying to use this tool and you encounter questions. So what's next? We've shown this process of looking at correcting 305 MEs, or in this case, 305 36 months, which we'll need to call them, but there's room for improvement in pretty much every single arm of this process. And so that brings me to a massive venture, a massive collaboration between CDCB and National DHIA and ourselves to update how we predict total lactation yields and estimate total daily yields. And so this is an experimental study which involves enrolling herds across the country that capture U.S. dairy systems demographics. Of course, there is more to be represented than just what I've listed here. This is our starting point with Holstein and Jersey, multiparous and primiparous animals, different grazing systems, and different milking frequency and potential robotic systems. This involves sampling cows for every single milking in their day on a weekly basis for the first 120 days of milk, and then using those weekly weights to predict their total lactation yields. And what we're trying to do here, our overall goal, is refine our prediction of actual yields as early in lactation as possible. The reason for that being that really important economic decisions are being made within the first 120 days of milk, so it's critical we provide a tool to guide those decisions about who to keep, who to cull, who to breed to whom. And we're very excited to share that this research has started. Our first pilot herd actually just wrapped up their weekly sampling. And so this involves collecting milk samples for traditional components, but also casein and fatty acids, as well as collecting all of the raw mid-infrared spectral data from the milk lab. And that's towards our secondary objective with this research of expanding their use in the prediction of alternative traits. We've also been collecting TMR samples from the same day that these milk samples are collected, because we do have a unique opportunity to relate the actual feed the cows consume with the components in the milk measured in the subsequent milkings. And all told, just in this early lactation data, we have about 68 million data points simply from our first herd. So we're very excited about this progress and what's next on the horizon. Now, of course, there's never enough time to share all the exciting things going on with you, so I want to take a minute to thank our enthusiastic industry and university collaborators who are bringing all of their talents and passion to the projects listed on this slide here. And I don't think I've forgotten any project or institution. If I have, I apologize. And I, of course, look forward to discussing and sharing some of this other research with you in the future. And so with that, I'd like to thank first and foremost dairy producers for making their data available for research use, the cows themselves for their compliance, and CDCB for their stewardship of the data and cooperation in this research. With that, I believe Kristen and I are available to take questions together, time permitting. Thank you.
If there are any questions, please raise your hand and I will bring you a microphone.
Yes, good morning. Quick question about milking speed. Any information on the genetic trends we're seeing?
Genetic trends? No, that's not something that we've, you mean over time? That's not something we've gotten to yet. This experiment does have a longitudinal design. Part of it is to answer the question, does a cow's milking speed change over the course of her lifetime? Right now, we're only able to compare primiparous with multiple parous animals, but of course there could be a big selection bias there with hard milkers being removed from the herd. So that is part of our goal, and as we start to collect data over a larger period of time, I'm sure that's something we'll be able to examine. Thank you.
We do have time for another question or two, if there are any. Otherwise, we will thank the ladies on the stage and give Robert the microphone.
Great. Thank you very much.
Well, good morning, everyone. And we're going to have a little bit of a change here. I won't be discussing genetics. I will be discussing an effort that the U.S. has been involved in through ICAR. So for some of you probably don't know who ICAR is and what it does, so I'll give you an update on that and what ICAR stands for. And probably you may not be aware of it, but I think most of you in this audience will have some involvement with the work that ICAR has done. And then I'll talk about the sustainability effort. So first things first, ICAR is the leading global provider of guidelines, standards, and certification of animal identification, animal recording, and animal evaluations. If you run a milk recording organization, your meters, your laboratories all follow ICAR standards. And it's not just in the US, it's pretty much worldwide. AI companies follow ICAR standards, genomic evaluations. The ID tags dairy farmers put in their cows, a lot of those follow ICAR standards. So historically, ICAR is a non-government organization. It was established back in 1951 in Rome, Italy. Their current headquarters is in the Netherlands. And they are the registration authority for the ID tags conforming to the ISO standards, and typically those are your low frequency, half duplex, full duplex tags that a lot of our dairy farms are applying to their animals with the 840 numbers. So ICAR is also looking at being a responsible entity in the dairy industry. So they want to contribute to a sustainable food chain and keeping in mind that's beneficial to open markets long term. Again, this is not just US, this is worldwide. So ICAR believes that an unbiased scientific approach provides the right fundamental framework for these common systems. So I'll give you a little flavor of who all participates in ICAR. All the countries you see here in dark blue are members. There's 132, 85 full members and 47 associate members across 55 countries, and several of the folks in the audience here, including myself, attend their meetings and participate in ICAR working groups. Amongst their core products and services, they set guidelines by which we operate. They have certification services, evaluation services, and a lot of seminars and workshops. And I myself serve as a committee chair on Animal Data Exchange Working Group. As you can see at the bottom, obviously a big player is Animal ID, which is important to all our efforts. Without Animal ID, we can't really operate. There would not be any genetic evaluations. Animal recording, everything we discussed this morning that's being recorded from milk weights, lab results, etc., follows through ICAR. Evaluations and animal data management. So that's a little bit about ICAR and the role they play in our ecosystem. So let's move to sustainable agriculture. So when somebody says, what is the definition of sustainability? I don't know if there's one definition that we can all gather around. It means different things to different people. However, the working group I was part of, we had to come up with a definition for the use within ICAR. So instead of coming up with our own, we actually found one within the SAI platform that you can read here. Sustainable agriculture, efficient long-term production of safe, high-quality agriculture product in a way that protects and improves the natural environment, the social and economic conditions of the farmers, their employees, and local communities, while safeguarding the health and welfare of all farm species. So that's basically the definition we started working with to figure out what role does ICAR play in this. So we had 2 working groups. This work originated almost 2 years ago, where we looked at what traits are we recording through our dairy recording systems that have an impact on sustainability. The one thing we came up right away was our role is not to build an index. It was pretty apparent that an index in the Netherlands or Germany or Australia would be quite different than an index we would define here in the US or Canada. However, the building blocks that go into that index should be standardized, because a lot of the retailers and processors of dairy products, they want something that is not calculated differently across the world. So if a country wants to establish an index, that's up to them. They can decide if certain building blocks need to be part of it or not and how they weigh them. So our role was to find out which key traits are we recording and maybe recording in the future that have an impact on sustainability. And then the second part is, what is the definition of those traits, and try to harmonize the methods of these key traits. So it breaks down in 2 sets of traits. One is through our milk recording systems, we have snapshot data. We gather information over monthly, bi-monthly. However, there's variability from month to month in the data, and we want to make sure that if we come up with a measure, it's not going to bounce around, from month to month on an individual herd. So we're looking at a 365-day period that takes into account geography. A herd in Texas is going to have more impact in the summer than the winter, while a herd up in Wisconsin might be the opposite, or the winter is going to have a negative impact. Seasonal calving, we got countries like New Zealand where they have seasonal calving, and also environmental environmental impact as it relates to the weather needs to be taken into account. And we sometimes see herd size fluctuation. So looking at these measures over a full year takes into account some of these variations. As I mentioned, there's two things that we need to look at snapshot data. Those are things that we measure maybe once a month or 10 times a year, like average daily milk on a herd, or counts. For example, how many animals were culled less than 60 days in milk over a 365-day period. So those are the two types of data points that we looked at. So how should you interpret test day snapshot data? Basically, you calculate a weighted average using the monthly points, or maybe there's only 10 in a year to come up with an annual number. And we would use all the test day data that's collected in that 365-day period. As far as counts and percentages, we would look at a 365-day window for the population that we will be counting against. And as mentioned here below, an example would be cows died within first 60 days in milk. We would use a window that goes back 60 days up to 365 plus 60 days and count the animals that were culled within a herd less than 60 days or died within less than 60 days in milk. There's a lot of traits. There's almost 40 of them that we define, and you can break it down in 5 groups. And here's just an example of some of the traits that were defined to have an impact on sustainability: feeding, fertility, health, longevity, and young stock. And you can each read some of the examples with each category. Here's an example of how we would calculate, for example, a test day based average. So we would take a herd's somatic cell count for a particular test day, multiply times the milk yield, and then divided by the sum of all the milk yields to come up with an annual somatic cell count. So this is typical data most countries are already recording, but as far as what is an annual average, that's probably not defined the same across countries. Another example here is percent cows culled due to lameness. So that's more of a count. So it would start counting in that 365-day period the number of animals and divide by the average herd size within that period, including dry and producing animals. In the case of lameness, sometimes cows are culled for more than one reason. Lameness needs to be one of them. So those are 2 examples of a lot of the calculations that have been defined by the working group that are available through the website. So that brings us to, so what are we going to do? All the information is published on the ICAR website. You can scan the code or you can go to the website listed below. But we want to make this available to the wider audience. Some countries have already moved forward. Canada has listed now some of these traits, and NMR in the UK has worked with Tesco, which is a big grocery store chain there, and working in this environment where you can see certain measures on farms. So it's usable data for hopefully the processors and retailers of dairy products, but also from a farm perspective, you can look at how are you changing over time? Are you improving on any of these measures? So the key is, this information needs to be shared with other partners like IDF and other members of the working group beside myself. I've had communications with them. I'm presenting here as a member of the working group. And the last slide here basically tells you the participants. So this was an international group. I was the US representative, but this was the second group. There was a first group which was a little bit larger that worked on making the list. This was all reviewed through the ICAR board. And now it's up to the individual countries to decide how they wish to implement this information. So in the US, we've started some of the discussions between the 4 dairy record processing centers, National DHIA, CDCB, about how we could establish a US-based standard for those traits that were defined by ICAR, and that can then potentially be used in building a US-based index related to sustainability. So that's what I had to present, and I think there may be some time, Katie, for some questions. I can't see where you're at. All I can see is a bright light, but maybe that's you.
Yes, we do have time for questions. So if you have them, please raise your hand.
I put my question in the app. Okay. It's okay. Hi, Robert. Thank you. I was wondering if CDCB could comment on how much of the guidelines they're actually considering to implement and how much change that would require.
So there's a question for CDCB, so I don't know who, Zhao, is that something you wish to address?
Regarding sustainability, well, that's what Robert was saying, that we are in conversation with the RPCs, National DHIA, also DMI. We have a conversation on that to discuss what would be the most reasonable approach. We have most of the traits that they included in the in the list at ICAR. We have it in the US, so we can consider using those in a potential index. We're not talking about genetic index here. We're talking about a herd index in terms of sustainability. So we haven't been yet in the phase of defining a prototype or something like that, but that's the conversation that is going on.
And for those of you that are in genetics, there are some traits in that list that include genetics. So it's about a lot of different things, and genetics is a piece of it.
All right, if there are not any other questions, we will thank Robert for his time and get Francisco up on the stage.
Perfect. Is it working? Yes. There we go. Good morning. Thank you very much for the invitation. It's great to be here. And today I will be talking about reducing enteric methane emissions from dairy cattle. Let me see if I know how to use this. There we go. As you know, methane represents 11% of the total US greenhouse gas emissions. And methane is the second most important greenhouse gas after CO2. And enteric fermentation accounts for 27% of total US methane emissions. And enteric fermentation from livestock is actually the second most important source of enteric methane emissions after natural gas and petroleum systems. As you know, methane is a very powerful gas, greenhouse gas. It has more than 80 times the warming power of CO2, and in the short term, methane sets the pace of global warming. Now, beyond the impact of methane on global warming, enteric methane represents a loss of energy, about 6 to 12% of gross energy intake. And enteric methane should be recognized as an energy sink, energy that could otherwise be available for growth or production. Therefore, there are multiple benefits associated with reducing methane emissions from dairy cattle, including reduce the environmental impact of dairy farming, and at the same time improve production efficiency. So given the importance of methane emissions, at the end of last year, we put together a large research grant entitled Integrating Genomic, Milk Spectrometry, and Microbial Manipulations to Mitigate Enteric Methane Emission from Dairy Cattle. We are a multidisciplinary team, including dairy cattle geneticists, dairy cattle nutritionists, and microbiologists from multiple institutions, including the University of Wisconsin, Michigan State University, Iowa State University, the University of Florida, and the USDA. And our overall goal is to reduce enteric methane emissions from dairy cattle by combining selective breeding, the use of milk spectral data, and rumen microbiome manipulations. Note that this is basically the same team that has developed and implement a national genetic evaluation for dairy cow feed efficiency, and the resources, the knowledge, the experience, the project management, and the communication gained in the past 12, 13 years will be now leveraged to reduce methane emissions from dairy cattle. This project has been funded by the Greener Cattle Initiative. As you may know, the Greener Cattle Initiative is a consortium created to support research that enables the mitigation of methane emissions. Here we have the founding members of the Greener Cattle Initiative. I want to thank the Greener Cattle Initiative and its program director, Juan Tricarico, for supporting this research. As you can see here, the Council on Dairy Cattle Breeding is one of the founding members, but we also receive matching funds from the Council of Dairy Cattle Breeding. So I want to thank Joao Dur, his team, and the board of directors for supporting our research. So our plan is basically to phenotype 4,000 lactating cows in 6 research farms over 3 years. So we will be measuring methane emissions and feed intake daily. And of course, we will measure milk yield and milk composition to compute milk energy, and we will have body weight, and we will have spectra data. And we typically run our trials between 6 and 8 weeks, between 50 and 200 days in milk. And as I mentioned before, our goal is to tackle methane emissions combining selective breeding, the use of spectra data, and rumen microbiome manipulations. We want to be the foundation for the development of genetic evaluation for methane emission traits. We want to evaluate the use of spectra data to predict methane emissions. And we want to reveal the composition and activity of the rumen microbiome of cows with extreme emissions, low and high methane emissions. And at the same time, we want to decipher the relative contributions of the cow and the microbes to produce methane. And for that, we will do some cool trials where we'll exchange ruminal contents. Regarding phenotyping, as you know, different techniques have been developed to measure methane emissions from respiration chambers. They are very accurate, but at the same time, they are very expensive and labor intensive, and hence are limited to a few animals. We also have the SF6 technique that is somewhat more scalable than the respiration chambers, but they need daily handling of animals, rumen bolus, and measurement of gas in the lab. We have the green feed system. We have sniffers. The sniffers are very popular in automatic milking system, and we have even laser detectors. So we decided to use the green feed system. The green feed system is a practical system that delivers reliable estimate of enteric methane emissions. The key to obtain reliable estimate is to obtain many short-term records measured at different time of the day for multiple days. So basically, the idea is to obtain multiple visits per day at different times of the day over multiple days. And our cows, they have access to green feed units 24 hours a day during 6 to 8 weeks. This is our setup at the UW Dairy Research Center in Arlington. This is our famous Pen 30. You can see here the blue gates where we measure daily feed intake. And we have now 2 green feeds where we measure daily methane emissions. This is data from our very last trial. We evaluate methane emissions in 58 multiparous Holstein cows during 6 weeks. As you can see here, multiparous cows produce roughly 450 grams of methane per day. But what is very cool here is that there is a very large variation in methane emissions across animals. We have animals that produce more than 600 grams of methane per day in one extreme of the curve. And we have in the other extreme animals that produce less than 300 grams of methane per day. And as you know, genetic selection requires variability among animals, and the variability observed in this small trial strongly suggests that genetic selection is one way to reduce methane emissions. In fact, selective breeding is a promising tool to mitigate enteric methane emissions. Methane emission traits are heritable traits with heritabilities between 15–20%. But methane is difficult to measure, right? Methane is difficult, it's hard, it's expensive. Now, in the genomics era, genomics has facilitated the selection for traits like methane emissions because we can phenotype a relatively small number of cows that at the same time we genotype, and then we can use this reference population to predict genomic PTAs for the entire population. So one of our goals is to develop a reference population for methane emissions, develop genomic evaluation for methane emission traits, and finally facilitate the incorporation into selection indices. Again, we are basically the same team that developed a reference population for dairy cow feed efficiency, and now we will develop a reference population for methane emissions. Now, talking about different traits, there are alternative methane emission traits. Of course, we have methane production, defined as grams of methane per day. And then we have methane yield and methane intensity. Methane yield is defined as methane production per kilogram of dry matter intake. And methane intensity is methane production per kilogram of energy-corrected milk. These two are ratio traits. Ratio traits, they do not have good statistical properties. We do not like ratio traits. Changes in ratio traits are hard to implement and interpret. So an alternative is to use residual methane. Residual methane production has the same meaning as residual feed intake. It's basically methane production regressed on or adjusted for dry matter intake, metabolic body weight, and or milk energy. So we have here 2 alternative methane production traits. This is data from our last trial, the 58 cows that I showed you before. Each dot here is 1 cow. So in the y-axis we have residual methane adjusted for dry matter intake, and in the x-axis we have residual methane is methane production adjusted for metabolic body weight and milk energy. So again, each dot is a cow. We have in the bottom cows that are producing roughly 100 grams of methane less than predicted. And on the top we have cows that are producing up to 150 grams of methane more than expected. What is very interesting here is that these 2 methane production traits are highly correlated, with correlations around 95%. Please note that residual methane, methane production adjusted for dry matter intake, can be measured on research farms, but residual methane adjusted for milk energy and metabolic body weight can be measured in commercial farms, and we are working on that right now. I told you that we will work also with milk spectra. As you know, spectroscopy is a very powerful phenotyping tool. Just think about it. High throughput, low cost, non-invasive. We can get real-time predictions. And milk spectra has been used to predict complex traits, including energy status in lactating cows, metabolic profiles in lactating cows, health status, and fertility, among others. And there is a very recent study from Canada. It's a study that uses a small data set, but the authors suggest that it's possible to predict methane emissions using spectra data. So our goal here is to determine the value of using spectra data to predict methane emissions. We will have more than 4,000 cows with methane emissions, and we will have the same cows with spectra data, so we will be able to determine the value of using spectra to predict methane emissions. Finally, we will work with the rumen microbiome of the cows. As you know, enteric methane is formed exclusively by methanogens in the rumen. Now, the interplay between the cow genome and the rumen microbiome is complicated, and we plan to reveal how the microbiome composition and activity affects methane production, but we also want to assess the relative contribution of the cow genome and the microbes to methane formation. And we can do that if we use structural equation models and graphical models. Just to give you a little flavor of what we can do, this is a research that we are doing right now, but with feed efficiency traits. So we have dry matter intake, milk energy, and residual feed intake. We have roughly 450 cows, and for each cow we have the genome, and we have the rumen microbiome. So basically in blue you have the typical heritability, the amount of phenotypic variance explained by the additive effects. And in green you have the result of a model that incorporates at the same time the cow genome and the rumen microbiome. And as you can see here with the little m, that is the amount of variability in the phenotype that is explained by the rumen. So the rumen microbiome explains between 20 and 30% of feed efficiency traits. The other cool result is that the direct heritability, that is the amount of phenotypic variance explained directly by the genome, is smaller than the total heritability, and that means that the rumen microbiome mediates part of the cow genetic effects. And in gray, those are results of a model that also include an interaction between the cow genome and her rumen microbiome. And as you can see, this interaction term explains part of the variability in the rumen in the feed efficiency traits. Our solutions, we plan to deliver multiple solutions. We want to be the foundation for routine genomic evaluation for methane emission trait in US dairy cattle. As you know, contrary to improvements in nutrition and management, changes achieved through genetic selection are incremental, cumulative, and permanent. That makes genetic selection for reducing methane emissions a very effective strategy. We will also deliver spectra-based solutions. If milk spectra is a good predictor of methane emissions, then we can use milk spectra to increase the accuracy of genomic evaluation for methane traits. But even more important, we can have real-time predictions of methane emissions. We can use spectra to optimize cow management in the dairy farm. With those real-time methane emission predictions, we will be able to assign some of these high methane emitting cows to some specific diets. Finally, we will deliver microbial solutions. At the end of this project, we will have a deeper understanding of how the host influence diversity and activity of methanogens, and we can use this knowledge to target strategies to reduce methane formation in the rumen. With that, I want to thank again the Greener Cattle Initiative and the Council on Dairy Cattle Breeding for funding this research. I want to thank my colleagues at the University of Wisconsin-Madison. They do all the work. They deserve all the credit. I want to thank the rest of the team. You have the list of the team here. Thanks for your attention, and I think I can receive some questions. Thank you.
Yes, again, if anyone has questions for Francisco, please raise your hand and I will bring you a microphone. All right, seeing none, thank you very much, Francisco.
Thank you.
Okay. Hello. So, my job is to take a motion to adjourn. But before that, I really would like to say that this program was intended to emphasize not only that we're celebrating successful progress over the years, but also that there's a lot going on and a lot of things to come. So we are very excited to address some of this. There's always some of these priorities that we are not addressing yet, but we are trying to optimize the resources we have in order to add value to our industry. I would like to thank first our speakers and panelists. I mean, without you, we wouldn't have a program, and you did a very good job. I'm really satisfied. I think most of us in the audience here would agree with me. I would like to also thank our current and past board of members. I think this collaborative effort between the sectors was a puzzle that has been put together by many hands, and it required a lot of investment from the representatives, but also from the sectors themselves. So, stakeholders, this has been really important. Of course, our eternal gratitude to USDA that handed over extremely powerful and efficient system, so that we just had to learn how it worked and keep it, make it continue to work with it. And they still help us in improving the system these days. Regarding the 10 years, I could not finish this event without remembering two people that took the first responsibility over the services, which were Dwayne Norman and also Lee Walton. They were retired from USDA, and they were brought back to the scene by the CDCB board, and during a year and a half they basically run the show until I got here and start to make things confused. But really these guys represented and still represent an extremely important chapter of this story. I would like to thank CDCB staff, and specifically I would like to thank Katie Schmidt and Amy DePlatte Church, which were instrumental in organizing this event and also putting together the annual report that you have in hands. I hope you read that and hand to other people, because I'm very proud looking back at this year and everything that has happened and everything that we managed to accomplish. Finally, thank you to our dairy producers, our collaborators. Without you, we wouldn't have a reason to exist. We wouldn't have a job, because really the only purpose of CDCB is to add value back to the producers. The questions that you had during the panel that were not answered, we will distribute that to the panelists and try to get the answers back to the participants. It just wasn't possible to cover everything. And one last thing, the speakers and the panelists, please come to the stage after we finish here because we want to take photos. With that, I would like to thank you very much, wish everybody a great World Dairy Expo, and say that we are delighted to have a full house and be able to share with you some of the things that we are doing and that we intend to do. Thank you very much. Have a great day.
Second, Miss Alexa Saride Ariel, ET, shown by Alora Sprout, Springville, Pennsylvania.